Hello, everybody, and welcome to another OpenShift Commons briefing. This briefing came out of a conversation that I had with Larry and Tim at Red Hat Summit back in May. And so we're going to do a slightly different format today than we usually do. This is going to be a bit of a conversation between Larry and Tim because Larry Brigman, who is the principal software engineer at ARRIS Group, had a whole bunch of conversations and thoughts about governance and containers and trusts. And Tim, on the other hand, is this wonderful developer evangelist person from Black Duck, which is now part of Synopsys, who has done a lot of great talks on just those things. And so the conversation that we had was so interesting that I thought I was going to try and make an attempt at recreating it as a briefing. So without further ado, I'm going to let Larry and Tim kick it off, and then we'll have some live QA at the end, and you can ask questions in the chat, and we may just figure out how to do live conversations with the whole group today. So take it away.
Cool. Thank you, Diane. And for anyone who's familiar with Black Duck as itself, we actually did the whole acquisition by Synopsys back in December. So same Black Duck, now with a little bit deeper pockets, a lot more resources on our side, but still doing exactly the same kind of stuff that we did before, only a little bit better, bigger, faster, stronger kind of thing. So if any questions come out of that, happy to take those on as we go forward. And thank you, Larry, for putting all of this together. We're going to try and, we do have a little bit of a deck in here, and we're going to try and run from one deck, so occasionally we may have to revert back to the proverbial click next of the world. So there's going to be a couple of stats that we'll have throughout the slides in here that come out of the Black Duck open source security and risk analysis report. This is something that we put out every year, and it looks at the commercial audits or audits of commercial software that the on-demand division of Black Duck has done for quite some time now. Last year was a little over 1,100 code bases that we looked at from about 500 companies. And so what we do is we digest the anonymized data out of that and put it out there. And anyone who wants to get a copy of it, that's actually on the last line. You can go click, fill out a wee little form on there, and we'll happily get you a download. If that doesn't work, definitely feel free to hit me up and I will get you a copy, no big deal. So let's try and go. So today's applications are fundamentally a case of a certain amount of proprietary code, fairly heavy reliance on open source components, some third-party APIs. It's starting to become more of a mashup world, and of course, my application's behavior and configuration is going to be different than Larry's, is going to be different than everyone else's, but that's fundamentally what the application looks like today. And the CNCF put out an analysis of their landscape application last fall that basically showed that their quote-unquote proprietary code represented only 0.1% of the actual code that was running to enable their containerized Node JS-based solution, and so that's a pretty typical scenario for what we see. And so click next. So from a governance perspective, the way I like to look at it is that what we're really trying to do is find ways to mitigate risk as we move through a software supply chain, that we effectively aren't the people who are left holding the bag. So for pretty much everybody who's on the call, open source license compliance is something that we're all aware of, that there are a multitude of options out there, and they all have their own nominally unique set of obligations. And as long as we're adhering to the obligations and we don't try and create too many weird, wonderful versions of our own, it's a fairly straightforward process to work through. There's also open source security, the use of vulnerable open source components. That was something that came to the fore with Heartbleed and OpenSSL 4 years ago, but it's still very much something that we see today, and it's, as you'll see in a later slide, a kind of ever-increasing daunting task. Something that I refer to as operational risk, which is really the identification of point-in-time decisions. So which component from which fork of which distribution channel is the version that makes sense, and why was that decision made, how are patches going to be brought in, who's going to be monitoring for any changes in functionality or API versions, and who's actually documented whatever the security response process for that project might be. Obviously, if you're getting a component from the Red Hat Container Catalog, it's going to have a pretty mature response process for any security issues, but if you go full upstream, your mileage definitely does vary. And as I alluded to earlier, API usage is something that we're increasingly seeing where it's a service-driven or an anything as a service, where I might, for example, have a credit card processor or something like that that's third party to me, but I need to attend to, well, what data is actually being passed? What are they doing with that data? If they change the contract terms, who owns compliance associated with it, and so forth. And so that fundamentally gets us into the license categories that we're all familiar with. I'm not going to go into this in great detail, except to say that from a global perspective, the permissive licenses that we are familiar with, the reciprocal licenses that we're familiar with, they may not necessarily map out when you start looking at things like whatever the legal requirements are in your particular geography. So for example, a public domain license is a concept that can exist cheerfully in the US, but may not exist in other countries. And so uncertain, unknown licenses, those are the ones you really need to pay attention to. And for practical purposes, all of these things ultimately get triggered by a distribution. So obviously, if you're working on a project internally, there's not really a distribution that's happening. If you're creating something that's going to be used internally by your employees, that's not really a distribution either. You start to bleed over into other license types when you create an application that's going to be used in a SaaS framework. If you have a conglomerate of companies, you may or may not have a distribution depending on what the actual usage is and where it's being used. Similarly, contractors and suppliers, that's something to attest to. And for practical purposes, most IP attorneys within an organization are going to be familiar with the core concepts of what to use, when to use it, and why to use it. But things do change. And Larry, if you want to click next, one of the things that surprised me, caused me to start thinking a little bit differently last year, was when someone asked the question, so what does it mean to actually push an image to Docker Hub? And so I thought about it for a second, and fundamentally, if you're pushing an image to any public repository, you've effectively distributed that binary. And so that means that whatever the obligations are that are associated with the licenses inside or for the components inside that image, those become your kind of joy of ownership. And so you need to start paying attention to those details. And from our audit, one of the things that we saw was that those code bases, 85% of them had some form of license conflict or unknown or uncertain license. And more alarming from my perspective was that 44% of them had some form of GPL conflict in play. And so as the complexity of software grows, being able to meet those obligations is a key challenge.
So to give you a context, ARRIS typically has been a hardware company, and a lot of stuff, their software is a secondary piece of their hardware. It's ubiquitous in that hardware, but now we're moving into providing services and applications to our customers. So we're, and in that case, we're needing to build applications that can be run in a multitude of places, like on Kubernetes and OpenShift, which means we have to do it in containers. And we need to be able to move quickly in that aspect. But a lot of things that are out there talking about containers never cover those issues that are actually always there. the licensing, the security, knowing what you're deploying, which is actually a bigger issue now with containers, and trusting what you're deploying. So I understand there's licenses, and the piece with a container, it becomes more like a Linux distribution or a mini Linux distribution because you have to acknowledge everything that's in there. And Tim mentioned it in his slide. When do we have to meet those? And he says when we push it, when we make that distribution. So if it went to a public repository or a customer site, we're now required to make those.
And so governance is increasingly shifting into regulators caring about data breaches. We see, for example, the GDPR. We see also other countries, not just the EU with GDPR, but Canada with something called PIP-EDA, and other jurisdictions starting to really take a hard look at what data breaches mean for their citizens, for the people that are there. And so if we click next, one of the things that I do in my day job is talk about how the technology is influencing decisions. And so last year, Maria Korolov published what turns out to be one of the more prescient articles in CSO magazine, basically that if you were going to have a security breach in 2017, well, that was likely to result in you getting fired. And kind of backing that up with a little bit of data, and click next, we have that IBM with the Ponemon Institute, just looking solely at the US data for last year, found that the average cost of a data, for the year before rather, found that the average cost of a data breach was a little over 7 million. Lost business was a little over 4 million. And the average time to identify and contain the breach was a bit over 6 months. Unfortunately for everyone, the story didn't get any better. So IBM published their data set for the 2018, looking back at 2017 last Wednesday, and they found that in the US, the cost of the data breach went up to 7.9 million, lost business went up to 4.2, and the average time to identify and contain a breach grew by 45 days. Now, they also put in a little bit of a footnote and said that they removed mega breaches like Equifax from this data set. And so the overall cost of a mega breach, such as what was seen with Equifax, simply is not part of this data. But click next. One of the things that we can say is that the Equifax breach really focused attention on what open source's role in modern technology stacks was all about. I've had quite a number of conversations with people over the course of the last 8-9 months that start out with, should I keep using Apache struts? Should struts be part of my environment? Should I move on to something else? And while it's a fair thing to continually reassess those frameworks, just because one organization has a breach or there happens to be a vulnerability in one framework doesn't mean that the next version of the framework or another framework isn't equally at risk. It all comes down to how you manage software in your environment, whether it be some internally generated code or a dependency on an open source stack like Apache Struts. So fundamentally, Struts is as good as it ever was and will continue to be so, and the community is very active there, and that's the kind of thing that we want to be able to see. Click next. But when we move into the world of how organizations build their security response processes, what we see is that there's a lot of assumptions that came from how proprietary software works. Things where you have procurement officers and you have dedicated security research teams and patch cadences and alerts about versions that may be going end of life or new versions or new security updates. Those vendors have a way to push that information into an organization. But when it comes to open source, it's exactly the opposite. Open source, we click next, is all about being able to engage with the community. If the community doesn't know that you've downloaded their component, they have no way to alert you to having a new security update, a new patch, a new hotfix, maybe end-of-lifing a version. And so community engagement becomes, quote unquote, the cost of ownership in the procurement model that needs to work to make the overall security posture of an open source environment more efficient. Click next. And so this is one of the things that we saw last year as well, that 78% of the code bases had at least one vulnerability, but there were an average of 64 vulnerabilities in each code base. That was an increase of 134% over what we saw in 2016. So the report looks at the 2017 data. 54% of the vulnerabilities that we found had high-risk vulnerabilities, but the more alarming stat for me is that the average age of those vulnerabilities was nearly 6 years. So we have a major long tail problem on our hands as an industry that needs to not work its way into containerized deployments, that the traditional app awareness model needs to change. So traditional security analysis is fundamentally blind to the way that open source works. We've got a lot of tools that are out there that can do a static analysis looking for bad code patterns or fuzz APIs. Those are all generally things that are going to be focused on the code that is created within an organization. Vulnerability analysis or software composition analysis, that's the term that the Gartner folks like to use, is looking at what is the risk associated with any of the dependencies that are coming in. And last year, there were over 14,000 new disclosures. That's roughly 40 a day. The alarming thing is that we're on pace so far in 2018 to top that number. And so being able to keep up to date with all of the new disclosures is a real challenge. Click next. And containerizing applications, it changes things in some respects, but it doesn't change everything. Click next. So I'll give a couple of examples. For a container design, the first thing that we start out with is determining what is our base image. And we're going to decide what components are going to come along for the ride. And then we're going to assemble them when we do a Docker build. That image is then going to be sent off for test. And we can use the fact that the image itself is a reusable component to facilitate our testing environment. Delivery fundamentally occurs when the Docker push event happens to push it into some registry. And the deployment occurs whenever we go and we deploy, say, a new OpenShift template or try and create a new pod, or we get a new deployment environment in place. And then when it comes time to do the patch, well, we don't use the same models that we have for traditional applications. We'll go and patch the container image and then use things like A/B testing in order to facilitate the deployments and update mechanism. And of course, we have the regulators who are defining whatever rules that we need to attend to as we move forward.
So this comes back to the point of knowing what's in your container. And part of that becomes what's, you know your application very well and its dependencies, but you don't necessarily know what is in your base container. And if you're doing a distribution of that container and knowing license obligations as most development teams do, you also need you own that container because you're distributing it. You need to figure out where to obtain patches and fixes and the like for everything in that container. So the piece here is, what's a team to do? It's really, containers kind of bring a new paradigm to this development model that has a lot. I think what we're going to present here is the very typical use cases, use of public containers and base containers, and the real question overall is, what of this can you trust?
And so when we look at trust, we need to actually take a little bit of a step back and say, what can go wrong? So the first thing that we need to identify is who actually owns that base image and what did they put in there. We need to identify what the health of that base image might be. So the Red Hat Container Catalog, for example, has a health metric associated with any image that can come from their public registry. The information that's in there, that's similar to a certain degree to what you can get from some images that are in Docker Hub, but not all registries are created equal. Not all registries are producing the information in the same manner, and there's not as much transparency as to how that health metric is being calculated. Plus, when you go to do a Docker pull, there's no mechanism in that protocol to actually say, I want the healthy version, not the one that is a little bit behind. And when you create the image, you're updating it at build time, and there's cache aspects that come in there. You trust your build servers. You have to start asking questions around how can containers start in the environment? Who's responsible for it? Who's responsible for modifying container images? If that base image registry goes away, do you have the facilities in which that you can rebuild it? If you're basing things on tags, what happens if the owner of that image decides to remove that tag because those are human modifiable components? When security disclosures happen, what are the process to determine impacts and so forth? These are all steps that are part of establishing the trust of the application when it's deployed. And we quite simply don't have enough time to go through every one of these in detail, but we have a couple of examples to talk through. And so the first one is looking at the image layer cache. So if you do Docker history on any image that you have in your environment, you'll see all of the layers and when they're created. In this case, I have an image that was built nominally 16 hours ago. I can see that as the first comment in there. That's highlighted in green. Highlighted in yellow is a set of copy operations that are pulling from a cache that was built 2 days ago. Highlighted in pink, 7 days prior, I have a yum update minimal of some security updates. And then 6 weeks prior, I have a base image that's coming in. And so if we roll this back chronologically, 6 weeks ago, the base image was created. A cache that represents that yum update was created 7 days ago. So anything that was patched between 6 weeks prior and 7 days prior is captured in that yum update. But every security update from the point of that cache creation forward is simply not applied. We don't have necessarily visibility into what the vulnerability state of any of the files that were copied in 2 days prior, but you can see here an example of how the image cache mechanism inside the Docker engine can pollute your expectations, because if you look solely at the Docker file, you'll see that the actual steps that you would expect to have to deploy a good application, they all exist, but the Docker cache in this instance kind of caused it to go off the rails. Look next. Another example is what if I want to pull images and I'm going to use one of the 3 models for pulling that image. I can either pull it by latest, I can pull it by a tag. So in this case, I've pulled latest. I'm scaling it to 2 replicas. I have 2 of whatever latest is. If I now pull by a tag of 101 and scale that up, I now have 2 replicas of that. And let's just assume for the sake of argument that they happen to be the same thing. I can then go and pull by the fully qualified pull spec, and I end up with that SHA 1, 2, 3, 4, 5, and I can scale that up. I can then also go and delete the tag and scaled 101 to 3 replicas. And the reason that this works is that the local Docker engine, if the pull specification for the image says that it can use the cache, well, it already has it in the cache, so it can scale it up. So now, what if I, say, 2 weeks later, go and add another node to my cluster, and meanwhile, development has happened on this image, and so there's a new latest, there's new things that can be deployed, and something happens and cluster node 1 goes down. What you effectively have is that OpenShift will then go and replicate the pieces that it can. So latest is a different color here because time has progressed and there's a different latest. The tag for 101 has been removed, so it can't be replicated at all, but the fully qualified pull spec still exists, and so it can. So you have an application that now is in a different state than it was before, even though everything looks like it should be, simply because activity has happened with respect to the registry that wasn't reflected from production. Click next. And the same thing can happen from the perspective of trying to do patching. So I can have a deployment config that I intend to use for A/B testing for my patch mechanism. I'm going to define a strategy that's going to roll forward, and I'm going to maybe have an automated patch mechanism that's going to detect that there's a new update and I want to move this forward. And in principle, this seems like a really good idea until you look at the patch history itself. And so if you click next, here's what the patch history for Apache struts look like for the 2.3 series over the course of the last little while. There are 3 distinct points in time where there were more high severity vulnerabilities that were present in a subsequent patch than in its predecessor. And so this is part of the automated assessment that needs to happen when looking at overall security patch models and when baking in what might be an automated scenario. And the last piece is looking at information flow. So there's a vulnerability that was disclosed in September for Apache struts. It was CVE 2017-9805. I've highlighted in yellow at the bottom what the description is, and I'll read little bits of it to the REST plugin in Apache struts versions between this and before that, and in this version before those uses an Xstream handler with an instance of Xstream for deserialization without any type filtering, which can lead to remote code execution when deserializing XML payloads. That's written in security researcher speak, which is not necessarily helpful to anyone who is actually trying to fix this or identify what would be in there. So if you click next. A better model might be to have a description that says Apache struts is a model view controller that has a plugin architecture supporting REST and AJAX and JSON. The affected versions of Apache struts, including these versions and this, using an Xstream handler for deserialization can result in remote code execution. Successful exploitation of the flaw can enable a hacker to gain full control of the affected server. And also, if we click next, include information that says something to the effect of, it's possible for some REST actions to stop working because of applied default restrictions on available classes. In such cases, please investigate the new interfaces that were introduced to allow new class restrictions per action. So in other words, functional changes crept in. So this type of information flow is important to successfully patch things. When you click next, you want to be able to also see if there are any workarounds, any mitigating activities that can be brought to bear. Or even more importantly, if you click next, you can see that there are a series of exploits that are available. So even if you might not be in a position to address the issue in your application at this particular point in time, having access to the potential exploits means that you have the ability to now test whether or not your application has some form of compensating control or mitigation in place against those publicly available exploits. And so that level of information flow is something that's automatically changing as time progresses. Just because in this set of screenshots, that's the way it looks, doesn't mean that 2 days later it didn't look differently.
So we're finally getting to the scenarios that I guess most teams will end up doing. Tim had a slide earlier about saying just like 1% of the total application is proprietary code. Turns out that this is a piece of your application. You're going to be using something like Influx or Prometheus. From your perspective, there's no value add except I need that service. So you provide a public container, and there's no modifications to that container image. There's no insertions. We're only using some configuration to say what's needed to say what ports and whatnot for our application usage. So we're going to be pulling this from an external registry. and it's not being distributed with our application. So what's the issues here? What's the benefits and drawbacks for using this type of thing?
So the scenario that I look at with this is I'm simply referencing this inside of, say, a template. This is an image that I want to have. I now have triggered from a governance perspective, a point-in-time decision. I'm going to be using this version of a component, and by extension, I should have something that says how it's going to be managed and maintained, effectively a runbook associated with it. I won't have necessarily any obligations associated with license compliance, because that's the responsibility of whomever pushed it. But if I subsequently go and pull this into, say, our own private registry, and then update the YAML for the pod definition or for the deployment config to, say, reference our internal or our public registry, now I'm taking ownership of that. And so there are subtle nuances to even a simple scenario like this that can create a governance issue on the license obligation side, but there's also the security side. That stock image was produced by somebody, and it may be, quote, the official image as determined by Docker Hub, but by extension, it doesn't necessarily give you any clarity as to what could be in that and what the components and associated risks might be.
All right, so let's go on to a variation of this same scenario. And I'm not sure it really makes any difference, but similar public container, we're going to be using something like Keycloak or maybe even OpenShift. We're not going to modify anything. We're just going to provide a overlay to change the visual representation. We need to make it look sort of like our application. And we're doing this from external of the image via config maps or mounts or init containers. And we're doing this the same way as the previous scenario. We're pulling it from an external repository, not into our stuff. It's deploying at the application runtime.
So this one, if we were to draw out a spectrum, our first scenario is about as easy as it's going to get. This one gets a little bit more nuanced because depending on what the application's licensing inside that container is, you could have something that maybe triggers a reciprocity clause. The canonical example for me would be if this happened to be a UI framework that was licensed under AGPL, the fact that we've created a theme, whether we're mounting that by volume mounts or otherwise, now could be a scenario where that theme needs to be redistributed. And so we have to have a level of awareness for what the license obligations are within the container. We have the same concerns about security. We have the same concerns about version management and lifecycle for that container image within whatever that public registry is. So we may need to internalize it, but fundamentally, it's the act of whatever licensing is associated with those themes that becomes the governance action.
So the themes themselves may not have that, but the application that we're putting it against may have a license that triggers distribution because of the application we're using.
Correct. So let's say that there was this was simply a UI framework that was licensed under AGPL, and AGPL says the entire experience is something that needs to be made available in source form. The fact that we have skinned this in some way to make it look like ours becomes now the obligation that needs to be met on our part.
Okay. Moving on. So we're going to provide a public service. We're going to use a public container again. We're not going to actually modify the actual running code, but we have to, the Docker scripts themselves didn't do a good job of managing best practices. So it's not running in OpenShift correctly without changing the security model. So we're going to fix that by changing the startup scripts only and user mappings such that we can run it as a run any. Still pulling from a public repository, doing the runtime deployment of this.
So in this variation, what we're looking at is an image that, for example, had a hard-coded user of some form, and do you want to go down the path of we care about modifying the security context within OpenShift, or we want to modify the image itself? Because it becomes slightly different depending on which path that we're permitted to go down.
Yeah, in this case, we have requirements that say we cannot run any users as root. We can't open up the security context for containers.
So there are two ways of solving this. The one way, and this would of course require security approvals from the governance folks, would be to create a namespace specific for this application that allows for that elevated security context and has additional monitoring in place to ensure that no bad things are going to happen. In other words, there are compensating controls for this. That's going to be obviously an internal conversation, and it's going to potentially expose that cluster to additional risks in the event of compromise. The second option is to go and effectively use that public container as if it was a base image, and then add some additional layers that are going to modify whatever the user mapping, security mappings are, and that becomes the entity that we've deployed. The moment that we now deploy that, that becomes our image, and the obligations that are part of that base image need to also be met by us. And so we now are triggering additional license governance issues in addition to the security governance issues, which is one of the reasons why I would prefer to see more non-root images as default out in the wild.
So we end up security context discussion within the team, or we end up owning it as a team.
Correct.
All right. So this is probably the most typical for distributing applications. We'll use a base container as our starting point, and we'll put our application dependencies into the container. And then when we send that out, we'll insert the configuration at runtime. Typical standard Docker, OpenShift, Kubernetes model.
Yeah, in this case, you're definitely, you're owning a lot here, but a lot of risk is also being transferred. So whatever that base container image is, if you can get something that is coming from a very trusted source, like say a Fedora-based image or a CentOS or a RHEL-based image, you know that that distribution channel is more trusted than if you get Tim and Larry's great and wonderful OS bundle, because Lord only knows what we've put in there and we've what our objectives were, even though it may work for the requirements. And it's not the way that you want to be building your base images, because the risks that we've created get transferred downstream. And so that's the whole supply chain risk model, and where you want to be holding as little of the overall risk as possible. So in this case, if you take a public base image from a very trusted source, and then you're adding your application and your dependencies that are in there, Obviously, your application is going to have its own set of obligations that can be met. That's more of a traditional governance model. It's going to have its set of dependencies, again, more traditional governance model that people are going to be familiar with outside of the container world. And configuration being done at runtime and deployment, that's pretty standard stuff. The distribution of that container image is obviously going to trigger license obligations. And so if something hasn't been met in that base image, then we may be on the hook to attend to it, depending on what our customer expectations are. But the overall security is now an amalgam of what that base image is and what our application's requirements are.
All right. So because we learned from the previous one, we're realizing that we need to take and build everything from scratch. Not the best choice from a knowledge perspective and time perspective, but security guys say, if we're going to own it, we should probably own everything. The piece here that may be interesting is if you're using like your application and dependencies are dependent on an OS like they typically are, you have you may end up needing to build your dependencies, may not. In this case, we know we own everything that is in that container. So any real issues here other than needing to be able to fix it?
So this is a scenario that I personally have gone down several times. And my personal preference is to build from scratch where possible. There is, however, one precondition. When building from scratch, one of the things that you'll want to ask is, am I using the correct development language? So for example, the goal should always be to have the minimum set of stuff inside that container image necessary to perform whatever function it needs to perform. And if, for example, you're developing in Java, creating a Java-based application means that you're going to need a JVM. Means that you're probably going to need more of a general purpose operating system, which means that building this from scratch is going to be a much more daunting task. If, on the other hand, you can work with a language like, say, Golang, that allows you to compile the entire application into a single binary, you're now in a much more manageable space because your entire image might actually consist of a couple of configuration files, maybe some form of TLS certificate bundle of one form or another, and then the Golang binary. So at that point, building from scratch doesn't necessarily have the management overhead that it could have if you have to go and determine, for example, what are the actual true dependencies this application has when it comes to the JVM's dependencies on user space components. And so that's precondition number one. Maybe the language choice is something that needs to be revisited. Then once that's in place, you're going to be making a large quantity of point-in-time decisions, because effectively what you're creating at this point is a full-blown Linux user space distribution. And you're going to be making those decisions based on whatever the application requirements are. So you're going to have the full gamut of license obligations, the full gamut of security obligations that are going to be part of this application and its associated dependencies. You may be in a position where going full upstream for these components is going to be the right answer. And so this scenario number 4, this is definitely one that I like. As I mentioned, I've done this a few times, but I've done it more successfully with Golang than I have with other environments, just because of the ability to compile to a single binary.
So Tim, this is Diane. I have to ask, because when someone says from scratch, I start scratching my head. and just want to qualify or ask you from your perspective. So at Red Hat, we have something called Certified Container Catalog. So we have a container that is a RHEL image, the middleware images, and HA proxy images, and they're when you're saying from scratch here, you're not saying, or are you saying build Linux from scratch, or are you saying pull one of these base certified containers from a trusted source and build on top of that?
Diane, that's a really good question.
I think actually what the question here is that what's the difference between the scenario, this number 4 and number 3? So number 3 is like what you're talking about, is where we would pull a certified image from Red Hat or Synopsys and then put our stuff on top of it.
Mm-hmm.
In this case, we're not pulling anything from a public repository. We may replicate the Docker file to build the container, but we will build everything or build that container ourselves and not reference external. So there won't be a from line that references a public distribution.
Yeah, so there's a, within the Docker file, the first line is always from something. And so you can create one that is from scratch, and scratch is effectively the null container, the null base image. So you're effectively saying from nothing. It's going to start with a 0-byte layer. And then at that point, the decisions are all yours to make for good or for bad.
But what you're asking, I think, is in part, Diane, are they building from source? They're building from binaries, sounds like.
Yeah.
And pulling from trusted sources. But yeah, and so I had a quick question. Do you run then a bunch of your own security tests against that full stack that you build from scratch?
So in our case, yes.
Okay.
Yes, so what we'll want to do is any APIs that are there, we'll run those through fuzzers. Any type of static analysis that we can do, we're going to run through that as well. We'll make certain that we have all of the dependency mapping in place, so we know where we're getting things from. So we, again, taking the Golang concept, that we don't end up in vendor madness. And end up being dependent upon something that was from somebody's random fork as opposed to true upstream. So we are going down that path, and what it does do is it eliminates more the potential for someone to go and use a latent component to go and do further bad things by just making it as small as possible and reducing the attack surface as much as possible.
Okay. But it's actual testing. So it's not like some statistical model that tells you when you put these things together, we don't think there's a security problem. It's actually testing it.
Correct. In the stuff that we're building, that's exactly what we're doing. We're running it through its paces and expecting that things are going to fail, and then as we encounter every single failure, going and doing the traditional test validation, verification, remediation, and so how to root cause analysis behind it.
Makes sense. Okay, thanks.
All right, I think we got everything here. We're going to move on.
And so effectively what we see is that we have to layer in as much as possible, that we want to have a secure platform. And so taking OpenShift origin or container platform, putting it on top of RHEL atomic host, or as Diane was saying, I think now to be called CoreOS, and putting in place the OVAL definitions to ensure that all of the infrastructural components are well attended to from both a policy as well as a security perspective, defining whatever security templates to apply. And then from our perspective, we believe that every single container image that comes into the environment should have some assessment that's performed. So we want to make certain that we're scanning and we're assessing every container image in the OpenShift deployment, be it ones that come by default or ones that are created by customers or what have you. And the moment that they're created or modified or updated. And that be something that's independent of the registry. That way you're never blindsided. But importantly, in the event that something is to be rolled back, that you have a way to understand what the current state of the system is. We also recognize that if you're running a production cluster, you don't need another console in there. So we want to annotate the pods, we want to annotate the image streams with whatever security information that's in place and actually update it in real time so that if there's a new disclosure that happened at the top of the hour, that you're never more than, say, an hour out from having that update applied and having that visibility, because information flow is really, really, really important. And so that effectively gets us to having continuous monitoring as a governance requirement. So our developers are going to do what developers do. Build systems are going to do what build systems do. And of course, risk assessment is performed at build and throughout many stages of the build pipeline itself and in test automation. They all have feedback mechanisms into defect tracking system. But once this deployment occurs and a Docker push occurs, and it's now in a production environment, the traditional mindset is, well, that this continuous monitoring piece becomes somebody else's problem. So if you want to click next, the goal that we have is that because we know what was actually part of that build, we know what is actually the composition of the things that are in there, why wouldn't we want to go and say, put a defect into a bug tracker or Jira, put a message out onto a Slack channel, for example, that an issue has come up, such that it can be attended to far quicker than it might otherwise be and get triaged appropriately at the outset. The core idea being one of, with all the regulators having continuous monitoring requirements in place, let's use some of the properties of the environment to our advantage. We don't need to go and throw an agent into every running container, or for that matter, put an agent on every host when we know that the container image is immutable. So let's use that property and move forward with it. So that's some of our thinking behind how to bring things at true scale into an OpenShift environment. I think this might be our last talking slide.
Yeah. The piece that I'm taking away from this is, as you're building your pipeline, your build, package, and test automations has a tendency to get more complex because you need to have that risk assessment piece with the feedback loop, which in traditional build environments, you may be doing that with static analysis and code coverage type things, but this is a new area when you're doing containers that has to be added on top of things.
Yeah, and I'll add in one additional piece of complexity that we see from our customers, that because of the ease at which container images can be recreated, if something gets discovered in QA or somebody screws something up, it's really easy to just redo that Docker build and push it out there. And so one of the struggles that we're seeing companies grapple with is, what does the actual lifespan of something being created mean within their governance model? So, for example, we have one customer whose view of the world is that every single container image needs to be monitored in perpetuity, or for 7 years, whichever comes first. And that's an enormous amount of data to have for things that were just a simple typo that got fixed and is now a redo of a Docker build. So I think that overall, the governance models are still evolving when it comes to container deployments, and we'll probably be still able to have a discussion like this next year, hopefully with a few more things ticked off that we would expect to have.
All right. So that covers everything that we had to cover.
I think you've done an awesome job, Larry, of like getting the questions answered, and I really appreciate it. There's one other question that keeps popping up in the chat, and the other Diane Fedema, has asked it a couple of times in different ways, and she's still wondering if anyone, and this might be the old school way, does bit-for-bit checks of public repositories to make sure that they're not being corrupted, you know, and I'm wondering.
So,
or do companies just avoid using the public repositories altogether just to avoid that problem?
So what I'm seeing is that it's more akin to, I don't want to be in a position where something could change the configuration of the public repository. Somebody could go and delete the image reference, that sort of thing. So I'm going to effectively bring a copy into whatever I'm using for my Docker registry or my binary repo. So at least I know that worst case, I've got a copy of this thing that's, quote, known good. And that's one of the point in time risks that we try and identify.
That makes sense to me too. And but then you're going to end up with if you're a developer like I am, or you're going to end up with repos that have like so many different images on them that still, that's another obligation.
Exactly. It comes back to that. At what point do we delete the thing because we know that nobody's using it, or that it's just become too old and crusty?
Yeah, and then I'm just like, I came from a scientific background, and with scientific data, like climate data, you periodically check to make sure all the bits are exactly what they were before. And so they do bit for bit checks. And I know people say other things are good enough, you know, like checksums and whatever is good enough, but is it really good enough? And like, so I'm just wondering, like, is there a company out there that's doing this for the public repositories and saying, you know, this image really is exactly what it was, you know, last year or yesterday or something like that?
So this is kind of, I've been using the tool that ships with OpenShift, and I don't know how to pronounce it. It's SKOPEO, that actually allows you to inspect a container. Scopio. Inspect the container metadata. And you can use that. It'll give you the digest, which is a SHA-256, and it will also expand out all the layers with a SHA-256. With that and a copy of your piece, maybe I'm making an assumption that the SHA-256 is hard to replicate. I believe they haven't found a collision on that yet. So I would trust that if you had a copy that you could check those two pieces against.
Okay. So people are doing their own checking, basically. Customers are doing their own checking.
Yeah.
Okay.
So, Diane, I think it might actually be to a certain extent embedded within the whole Docker daemons layering system. So there's a SHA-256 that's created for each layer. And I think at this point, there might just be an implicit assumption on people's parts that the Docker daemon is in fact checking that in real time. I'm not entirely certain that what you're asking is actually being performed by anyone independently.
So the Docker daemon does that itself? That's built into its functionality?
I believe that that's part of how it does the pull. So it has an expectation that the SHA should be this. When it does a pull, it goes and it recomputes the SHA and does a SHA match.
Okay.
So I think that that would be a great topic for another OpenShift Commons briefing, to get someone to dive deep into that from the Scopio team and the daemon stuff, because I think that clarifying that would be great. And we are at the end of our hour, so I want to respect people's time here, and thank you guys for doing this. I don't see too many more questions or any more questions. Oh, sorry, I spelled it wrong. It's Skopeo, Skopeo, and I'll get someone to come and do a deep dive on Skopeo and talk about what the Docker daemon is actually doing when it pulls it in, because I think we need to clarify that a little bit better, and we've got some definitely Dan Walshish type folks out there who can come in and deep dive on that, and there's a gentleman, I'm pretty sure he's in Italy, I can't think of his name, who's also a very good speaker on that topic as well.
And Diane, I would add in on that topic something that's of interest to me as well, is the whole act of signing an image. So in other words, how do I actually know that the image that I expected to get was the image that I got?
I agree, image shining, and that's a perfect sort of combination, and another conversation that we should have. I really do want to thank you guys for taking the time and sharing that conversation that we had at Red Hat Summit in this format. I think it was useful. I actually think it was interesting to have the end user perspective driving what the questions were here today, and I'll try and reproduce it again. And thank you, Tim, for taking the time. And folks on the call, if you are not in the Slack channel, OpenShift Commons Slack channel, and you'd like to be, just reach out to me at dmueller@redhat.com, and I'll add you in. And we can continue these conversations there and on the mailing list. So thanks, guys. And if you can send me your slide deck, I will also include that when I upload it all to YouTube later today.
All right.
Thank you, Diane.
Thank you, Diane.
Thank you, everyone.